Howdy. Welcome to Ionic Bonds. This space with Science 9, Matter and Chemical Change. Let's get started. So first things first, what is an ionic bond? An ionic bond is when a metal and a non-metal combine together, and it is made from ions. So remember, an ion, for example, for a metal, is when metals lose electrons. When they lose electrons, they become positively charged, whereas non-metals gain electrons. When you gain electrons, become negatively charged because electrons are negative. Remember that ionic compound is made from ions. And so this is an example here. So when this element here loses this electron going this way over here, it makes this overall element positive and our non-metal negative. And they attract to each other because opposites attract in something called an electrostatic attraction. You're welcome. Okay, we're going to look at how to name these ionic compounds. So the first thing you got to do is you got to look at where does this break apart. So I'm going to break it apart here because I know that the lowercase letter is always attached to my uppercase letter. So I got to find that Na symbol on my periodic table. So I pull open my periodic table and I look and I notice that sodium is found right here in group 1. I'm going to pull that out for you. There it is. So Na is sodium. Over here, I'm going to look for my non-metal, my periodic table, and I see it's over here in my group 17, my halogens. I'm going to pull that out, and F is fluorine. Now I take my two names and I stick them together. You write them the exact same way they're found in the periodic table. Remember, metals go first, followed by your non-metals. Now the key thing here is we actually have to change this second word. So I look at my vowels. So here is my first vowel, here is my second one, and this is where I truncate it or I break it off. When I break it off here, my ending changes from an INE to an IDE. So instead of sodium fluorine, it's actually sodium fluoride. Okay, let's try that again. Where do I break this? I break this right here because these are my two elements. I need to find Be on the periodic table. Bam, periodic table. I look and I see this is my group 2. It's an alkaline earth metal. I'm going to pull her out. Be is beryllium. I look at my non-metal periodic table and I check her out. It's group 16. I pull that out. O is oxygen. I'm going to slap these two together. I got to figure out where do I truncate that or where do I break it. So I'm going to take this and look for my vowels. Here's my first vowel. Here's my second vowel. So I break it right here. So it's not beryllium oxygen. It's beryllium oxide. Okay, another one. MgCl. Where do I break it? Right here, right? Remember that lowercase letter always attaches that uppercase letter. I'm going to look for Mg first. Where's Mg? Yo, there it is. It's an alkaline earth metal again. Let's pull her out. Mg is magnesium. Our second one, Cl. Let's find her. It is a halogen right here. I'm going to pull that Cl out. Cl is chlorine. So I write them together. Remember, I got to figure out where I truncate that because you always change the second element to IDE. So here's my first vowel. Here's my second vowel. I'm going to boop, chunk it off right there. When I take that off, remember, it becomes magnesium chloride. Okay? Let's try our next one here. So where do I truncate this again? Bam, right here. Why? Because remember, the lowercase letter always has to be attached to that uppercase letter. Let's find that Li first. Li is found in group 1, your alkali metals. There it is. I'm going to pull that out. Li is represented by lithium. So there it is. I'm going to look for my non-metal now. My non-metal is over here in group number 15. I'm going to pull it out. My nitrogen. My N is nitrogen, and there it is. Remember that this is my metal and this is my non-metal. When I have a metal and a non-metal, that means it's an ionic compound. I'm going to write them together, but stop, hold up, wait a minute. We're not done yet. We got to find those vowels, always starting from the right-hand side. Here's my first vowel. Here's my second vowel. Bam, that's where you cut it off right there, my friends. So it becomes lithium nitride. Remember, this is what I'm looking for, okay? And notice there's a space between the two words. That's really, really important. All right, let's go the opposite direction now. So see, I have my sodium chloride. I need to figure out, first of all, what is sodium? Pull up my periodic table. It's right over here in group number 1. Let's pull it out. Sodium symbol is Na. Now, the key thing here is I need to keep track of this ion charge because ionic compounds are made from ions that are solid at room temperature. So I need to keep track of that positive charge. So I write it right here. This is important. I then need to find chloride. Remember, chloride is actually chlorine. So I find her in group 17 over here. And so look at that, chloride. Chloride is chlorine, so it's Cl. And once again, I got to keep track of that ion charge. So it tells me chlorine likes to gain one electron, whereas sodium likes to lose an electron. So now I have to balance these. So what I do is I draw my little ions. So I'm going to draw an ion here for sodium, that's positive, and then I draw an ion here for chlorine, which is negative. In order to be an ionic compound, it has to be neutral. That means my positives and my negatives need to cancel out. So I have one positive, one negative. Oh, it's perfectly equal. I'm good to go. So I write down NaCl. Notice I never put a 1 or anything, because if you write the letters, it's automatically assumed to be 1. And now it's ionic compounds, and ionic compounds are solid at room temperature. Let's try our next one, lithium sulfide. I got to find lithium symbol first and its charge. Lithium is group number 1. It's right here. Bam, pull her out. So here it is. And notice my positive 1 charge is here because it's lost 1 electron. Sulfide is also called sulfur, right? So that is actually found in group 16 over here. I'm going to pull it out. And notice there's all these extra charges here. Just ignore those. Take that top charge. Remember that group 16, the entire row has a 2 negative charge. The entire column has a 2 negative charge. The entire column of your halogens is -1, and the entire column over here, nitrogen and phosphorus, is -3. All right, so there are my 2 charges. So I'm going to draw my 2 little ion bubbles. So lithium is a positive, sulfur is a 2 negative. Now I look at these and I decide, are these equal? Hopefully you say no, because if I add these together, I'm left with a negative still here. So I need to add another positive over here. Notice that whatever my charge is here is what I draw in each one of these bubbles. So now I look. Over here I have 2 positive. Over here I have 2 negative. If I add them together, they will equal 0. So I am good to go. So my symbol is this, Li. I count them. I have 1, 2. So I place a small 2 here to represent 2 lithium. And then I draw a capital S. Do not write the 1 for the 1 because we write the symbol. And now it's an ionic compound, so therefore it's solid at room temperatures. All right, next one here, magnesium fluoride. Let's find magnesium first. Magnesium is over here in a group 2. Bam, pull it out. I'm going to write it like this. Remember, ion charge is written right here. That means it lost 2 electrons. Fluoride is fluorine. It's found in group 17. Bam, pull her out right there. Right? Here we go. Notice here's my 1 negative charge. Here's my 1 negative charge. Let's draw my ion bubbles to balance it. We have 2 positive here for my magnesium, and we have 1 negative here for my fluorine. I look, are they equal? Will they balance out? No, I have an extra positive. So I need to add another negative over here. So now on this side, I have 2 positive, and on this side, I have 2 negative. When I add these together, I get 0. It is neutral, therefore I'm good to go. So to write my formula, I write Mg. Do not put anything down here because it is 1. And then I write my capital F, and then I count my ions. I have 1 ion, I have 2 ions. So I put a small 2 or a subscript. And it's solid because ionic compounds are made from ions that are solid at room temperature. Next example, aluminium. Aluminium, find her on the periodic table. Whoa, it is crazy. All over here in group 13. So group 13, here's my aluminium. Aluminium, here's my charge. Means it's lost 3 electrons. Oxide, what's oxide? Look on the periodic table. I find it in group 16. Here it is. Pull it out. Oxide is oxygen. And I write this charge along with that. So I'm now going to draw my little ion bubbles right here. 3 positive and 2 negative. Now I look, are they equal? They're not equal. So I'm going to draw another one on the smaller side. Now notice I still put a 2 negative there because whatever charge it is always has to be the exact same in there. I can't write it any different. So now on my metal side I have 3 positive. On my non-metal side I have 4 negative. Are they equal? I'm hoping you're saying no. So over here, I need to add, you guessed it, 3 positive. Why? Because it's 3 positive here, so I have to put 3 positive in each of those. Now, I got 6 positive on this side and 4 negative. I'm still not equal. Let's add another ion bubble over here. So now I can see that I'm 6 positive, and on this side here, I am 6 negative. So when I add these together, it equals 0. So my formula is going to be L, I count them, 1, 2 ion bubbles, 2, O, I count my ion bubbles, 1, 2, 3, 3. And what's my state? You guessed it, solid at room temperature, because ionic compounds are made from ions and solid at room temperature. All right, my friends, let's recap this. To go to formula the name, you find the metal and the non-metal. The metal, and change the end of the non-metal to IDE. Look for that second vowel. To go from the name to the formula, you got to find the symbols and the ion charges. Remember, you balance the ion charges until the compound is neutral. You cannot change the ion charge. Okay, you write the formula with the subscripts, but not the one. Thanks for watching, my friends. Have a sciencey day.